Example 1 asks us to write the vector CG in 3 different ways. Let's start by having a look at vector CG. Vector CG tells us to start at point C and travel to point G. So we put the tip of our vector at point C and we put the arrow or the head of our vector at point G. So this vector has both a magnitude or length as well as a direction. We need to find another vector in this diagram that has the same magnitude and the same direction as vector CG. The obvious choice here is to look at vector GF. If we travel from G to F, then we've just created a vector that is identical to vector CG. This vector has the same magnitude and direction as vector CG, so we can write that CG vector equals vector GF. Make sure that you write those letters in order. If you write vector FG, then you have changed the direction so that the direction of this vector would be opposite to that of CG. So another way to write our vector CG would be to write it as the sum of 2 other vectors in our diagram. What if we were to travel from point G to point D and create a vector there in that direction, and then travel from point D back to point C along this vector? The sum of those vectors from here to here and then from B back to C would be equivalent to vector CG because you would end up at the same spot. So vector CG is also equivalent to the sum of vector GB plus BC. Now if we want to get a little more fancy, we might want to try to find a vector that is equivalent to CG in a different way. What if we look at vector BE compared to vector CG? These vectors are also the same magnitude and the same direction. So vector CG is equivalent to vector BE. That's an E. So there we have 3 representations of vector CG. There's lots more in this diagram. You can practice and compare your answers to the ones that I've got here. And if you want to check and see if you're right, don't hesitate to email me.